Okay, this is a video that supplements the Unit 1 test review for geometry. So let's take a look at these. We want to name the following ray in two different ways. So the ray starts at A and heads through B and C and keeps on going forever off to the right. So the starting point of the ray needs to be A. We can talk about ray AB or ray AC, both naming the same ray. For number 2, we want to find the length of the segment A to C. So one way is to look at A as being 9 units to the left of 0, and C is 7 units to the right of 0. So together we have a total of 16 units of distance. The other thing we can do is subtract the coordinates. We can do the coordinates of point C, where this is an absolute value idea, take away or subtract minus the coordinates of point A, which is a minus 9. So we're doing 7, take away a minus 9, and take away a negative is the same thing as a plus. That gives us absolute value of 16, which is 16 units of distance. The reason we use absolute value is because distance is always going to be positive, and the order doesn't matter. We also could have done negative 9, take away 7, to do in the opposite order. That would give us absolute value of a negative 16, which still comes out to be 16. So in terms of the notation, we could say AC equals 16 without the segment mark. AC equals. Let's move up. In the diagram below, find the measure of X, BC, and AC. So using the segment addition postulate, we have AB plus BC. The distance from A to B plus the distance from B to C is equal to the distance from A to C. That's segment addition postulate. Now we can substitute in. For AB, we can put in X. For BC, we can put in 2x plus 3. And for the length of AC, we have 4x minus 12. And then we combine like terms. So this is a substitution. Then we're going to combine like terms. So we get 3x's plus 3 equals 4x minus 12. Take away 4x's from both sides. Minus x plus 3 equals 12. Take away 3 from both sides. Minus x equals 9. A minus x is 9, so the opposite of x is going to be the opposite of 9, which is a minus 9. So we get x is a minus 9 for this one. Now when we think about it, minus 9 is a problem because we shouldn't get a negative when we are doing distance. So let's see where the mistake would be. Right here, this was 4x minus 12. I counted as a positive 12. That should be a negative 12. And now when I take 3 away from both sides, this should have actually been a negative 15. And then the opposite of a negative 15 is a positive 15. So x should be 15 for this one. So we found out what x was. X was 15. We want to find the length of BC. BC is 2 times 15 plus 3, which is 33, equals the distance from B to C. And then the distance from A to B is just x, which we found out was 15. So there's our 3 answers for that one. Let's look up here. E is the midpoint. Now midpoint means divides the line into 2 congruent parts. So this piece and this piece are congruent to each other. which means that we can set their measures equal to each other. 3x plus 3 equals 5x minus 11. So because the midpoint, AE equals EG, and then we substitute those in. Take 5x away from both sides, minus 2x plus 3 equals minus 11. Take away 3 from both sides, minus 2x's equals negative 14. And divide both sides by negative 2, x equals 7. So all we had to do on this one was find out that x is equal to 7. If we did need to know the length, 3 times 7 plus 3 is 24. That's a check. 5 times 7 is 35. Take away 11 also gives us 24. Let's look at number 5 and 6. We'll want to find the measure of CAB in this diagram. Okay, CAB, that's this distance here, or this measure here. It's telling us that this whole length here is 110 degrees. And I'm taking it that this distance here is 70 degrees. And we can see that 70 plus 40 makes the 110 degrees. So really we've got like 70 plus x equals 110. Take away 70 from both sides, x is equal to 40. So we can see that this has to be 40 degrees for the measure of angle CAB. Here they're telling us that this is our angle bisector. Ray DB bisects the angle, so we have two congruent angles, which means these have equal measures. So we could say, to set this up, the measure of angle ADB is equal to the measure of angle BDC, and that would be definition of angle bisector, which gives us 2x plus 13 equals 5x minus 20, because these two pieces have to be equal then. Take away 5x from both sides, minus 3x plus 13 is equal to minus 20. Take away 13 from both sides, minus 3x's is equal to minus 33. Divide both sides by negative 3, we get x is equal to 11. It wants to find the measures of the angles, which should be the same. So 2 times 11 plus 13 comes out to be 22 plus 13, which is 35. And if we did it the other way, 5 times 11 minus 20 gives us 55 minus 20, which also gives us 35. So the measure of those angles is 35 degrees. Let's look on. Okay, basic constructions. Bring this in a little bit. So I think we have to name these in order. So let's see what we got here. Okay, so we want to number these in order. So if I was to sketch the process of an angle doing a bisector of an angle, we've got the angle. Then we're going to do an arc. Then we're going to find the points on this arc and strike another arc and another arc in the center. And then we're going to connect that with the vertex, that intersection with the vertex. So the first step on here is draw two intersecting arcs with the same radius. One centered at one. No, it's not that one. Draw arcs with the same radius centered at P that intersect PY and PA. This is step 1. That's this part right here. So we do this. Step 2, you're going to do this arc here at Y and A. So this is step 2. So we do this, and we do this. Then, using a straight edge, draw the line through P and X. And then we label the intersection of the two arcs X, step 4. So that's the order of the steps that goes with this one. Which segments would be congruent in the diagram above? Well, since we're using the compass to strike this first arc, we're actually finding this distance and this distance as the same, and then also from y to x, since we're using the compass, and from a to x, since we're using the compass. Even though the segments aren't on there, we could kind of think about this segment and this segment also being congruent because we're doing the same arc. And then this segment and this segment are congruent because these are using the same arc starting at P. So for sure, with the diagrams as drawn on the diagram, we have segment PA and PY. Let's say P, those are congruent. And if you want to do a little bit more advanced and think about a segment that could be drawn, we also know that the distance from y to x is equal to the distance from a to x. So we know that yx equals ax, which if we had segments would give us segment yx congruent to segment ax. Okay, let's move on. Midpoint and distance. We want to find the midpoint of this line segment. So the best method for doing this is just draw a segment and label the endpoints with the vertices you have. It doesn't have to be to scale or in the right direction or anything like that. And what we're really doing is we want to find the midpoint of the y's. So if we do 11 and 6, we get 17. So 17 over 2 is going to be the midpoint coordinate of the y's. So we're doing y1 plus y2 over 2, and that came out to be 17 over 2. And for the midpoint of the x's, you want to add the two x's and divide by 2. There's like the formula that goes with it. We have 5 plus a negative 3. A 5 plus a negative 3 is a 2. So we get 2 over 2, which simplifies to 1. So we have 1 and 17 halves as the coordinates of that midpoint. So I'm going to show it's a midpoint by putting corresponding congruent marks on it. And again, this doesn't have to be to scale. You just want to kind of sketch it as a reference. Here we want to find the missing endpoint if A has these coordinates. So there's a formula way to do this, and then there's kind of like an intuition way. Let's do the intuition way first. The midpoint is at -1, -3. And one of the endpoints is at 4, 7. And this xy is the other one that they want us to find. So one way of doing this for the y, to find this y number, is to look at how you have to move in the y direction as you go from 7 to a -3. That's a total distance of 10. You're 7 on one side of 0, 3 on the other. This is a jump up of 10. So you're jumping up 10 in the y direction. So you jump up another 10 from the -3, and a -3 and 10, I'm doing the wrong way here. You're actually subtracting 10 to get to -3. So we're subtracting 10 from -3, and we get -13. So the y coordinate of this endpoint is -13. Do the same thing for the x's. To go from 4 to a -1, which is the horizontal distance, you're going -5. So you continue on another -5, and -1, take away 5 more, gives you -6. So the coordinates of this midpoint are going to be -6 and -13. Now here's the formula way to do it. We've got x1 plus x2 over 2 equals the x coordinate of the midpoint. Now they're telling us the x coordinate of the midpoint is a -1. And also using the y's, y1 plus y2 over 2 gives us the y coordinate of the midpoint, which they're telling us is a -3. Now the other information that they're giving us is that x is a 4, and y is a 7. So I'm going to put those into each one of the parts of the formula. So 4 plus x divided by 2 equals negative 1. Multiply both sides by 2. We get 4 plus x equals negative 2. Then I'm going to take 4 away from both sides. X equals negative 6. And over here we have 7 plus y over 2 is equal to negative 3. Multiply both sides by 2 to get rid of the denominator. 7 plus y equals negative 6. Take 7 away from both sides. Y equals negative 13. So we get the coordinate of the midpoint as negative 6, negative 13 using the formulas. Let's look at 11. We want to find the coordinates of the point that's 3/4 of the distance from D to E. So we're going to do 3/4 of this distance and 3/4 of this distance. So we got to find the distances. So and they're counting by ones. So we got 1, 2, 3, 4, 5, 6, 7, 8 in the x direction, and 1, 2, 3, 4 in the y direction. So again, we're kind of pretending this is like a right triangle here. Now from D to E, we're going from D to E. So if we want 3/4 of this distance from D to E, we want 3/4 of 8. So we do 3 over 4 times 8 over 1. That gives us 24 over 4. Remember, multiply fractions, numerator times numerator, denominator times denominator. That gives us 6 for the x coordinate. And doing the y's, we're going to do 3/4 of 4. So that's going to be 3/4 times 4 over 1, which is going to give us 12 over 4, which gives us 3. So over 6 and up 3 from the endpoint. Now this is the distance from the endpoint. So over, let me change colors. We're going to go over 1, 2, 3, 4, 5, 6. We're going to go up 1, 2, 3. So there's the point that's 3/4 of the distance. This is 3/4. This is 1/4 of the distance between those. And the coordinates of this is 6, 3. So for distances, we're doing whatever this is times the x distance, adding it to the end of the x's, or the end point of the x, and we're doing the same thing for the y distance and adding it to the whatever the y is that goes with the end point. So look at number 12. So Arthur, Jamie, and Cameron are all playing soccer. Which player is closer to Jamie? So here's Jamie. So the distance from Jamie to Cameron is this distance here. And the distance from Jamie to Arthur is this distance here. So we want to find those distances. So this is where our triangle approach comes in. Pretend this is a right triangle. And we want to find out what this distance is. So we're going to use the Pythagorean theorem. A squared plus b squared equals c squared, where a and b are the side lengths. So 1, 2, 3, 4, 5, 6 is the x distance. And then the y distance is 1, 2, 3, 4. And that's going to be c squared. 6 squared is 36. 4 squared is 16. That gives us 52. And we want to know what c is, so we're going to take the square root to get the distance. So this distance here is the square root of 52, which is a little bit bigger than 7. Call it like 7.2. Now we got to do the same thing for this other distance over here from Jamie to Arthur. So let's see what we got. Let's draw the triangle. Sketch the triangle rather. We have a 1, 2, 3 distance in the x direction. And we have a 1, 2, 3, 4, 5 distance in the y direction. So using the same formula, we've got 5 squared plus 3 squared equals c squared. 25 plus 9 equals c squared. C is going to be the square root of 25 and 9, which is 34, which is a little bit less than 6, so call it 5.9. So, which player is closest? Looks like Arthur is the closest player. Let's move on. Conditionals, biconditionals. Consider the statement, 2 angles that are congruent have the same measure. Use this statement to fill out the table below. Okay, we want just the original conditional statement. If 2 angles are congruent, then they have the same measure. And that's a true statement. We want to form the converse. Now the converse swaps. So we got if P then Q for the original statement. The converse swaps the Q's and the P's. So we have if Q then P. So this is going to be if 2 angles have the same measure, then they are congruent. And this is also a true statement. 2 angles have the same measure, then they are congruent. That's a true statement also. Let's do the inverse now. Now the inverse keeps the original order, but adds not. So not P, then not Q. So if 2 angles are not congruent, then they do not have the same measure. So if 2 angles aren't congruent, then they don't have the same measure. That's also a true statement. And we want to form the contrapositive. Now what the contrapositive does is swaps the Q's and the P's and then makes them opposite. So it's the negatives added to the converse. So if 2 angles do not have the same measure, then they are not congruent. So let's think about the truth value. If 2 angles do not have the same measure, then they are not congruent. That's also a true statement. So those are all true statements. Okay, for 14, for this conditional, we want to determine the truth value, then write the converse, and also check its truth value. Now, if both of those are true, that means we can write it as a biconditional. If they're not true, we can't write the biconditional. So let's see. If 2 angles form a linear pair, then they are adjacent and supplementary. So there's our conditional statement. Now the P part of this, 2 angles form a linear pair. The Q part of this, they are adjacent and supplementary. The converse swaps the Q's and the P's. So if 2 angles are adjacent and supplementary, then they form a linear pair. So let's see. So if two angles form a linear pair, they're adjacent supplementary. That's a true statement. Now, if this statement is also true, we can write it as a biconditional. So if two angles are adjacent and supplementary, then they form a linear pair. That's also a true statement. So the biconditional would be two angles form a linear pair, if and only if they are supplementary. And this can only be written because the original statement and its converse are both true. If one or the other was false, we could not write the biconditional. So this biconditional is going to be a true statement. Because both of these are true, we can write the biconditional, which is going to be a true statement. And biconditional if and only if. Okay, let's look at number 15. Use the law of syllogism to write a statement. So we have, if we use kind of like the notation, P goes with Q. And then over here we have Q goes with R. Since P goes with Q and Q goes with R, Q, by the law of syllogism, connects P with R. So we can say if an angle is less than 90, if an angle measures less than 90, then it is not obtuse. So the Q connects with the Q of the last statement, and it leaves the P and the R both linked together. Okay, let's look at part 5. Let's see. If FGK is 35, so FGK, this is 35 degrees, and FGJ is 62 degrees, find the measure of KGE. Now, a couple things going on here. Looking at the diagram, we see that this FGH angle is a right angle. If one piece of it is 62, the other piece needs to make up the 90 degrees. That's going to be a 28. And on this side, too, we have an adjacent angle that also needs to be supplementary. So this angle DGF needs to also be 90 degrees. And 35 and 45, right? 35 and 55 makes 90 degrees. So this is a 55. And now we got everything that we need to answer the questions. So KGE, 55 degrees. JGH, 28 degrees. And FGE, 90 degrees. Let's look at 17. Here's an example of vertical angles. Angles that are on opposite sides of an X are vertical angles. They share a common vertex, and the sides make up the other opposite angle. So these angles have to be congruent because they're vertical angles. So vertical angles are congruent. And we can say that 3x equals 2x plus 16. Take 2x away from both sides, x equals 16. And all we had to do was find the value of x. If we didn't need to know the value of the angles, plug it in, that'd be 48. And this would be 32 plus 16, which also would be 48. But they want us to find that x was equal to 16. Let's look at this proof for part 6. And let's see what we have here. So given that the measure of ABC is 94, this big angle here is 94 degrees. There to there. We can see that these two together need to be equal to 94, and then we can solve for x. So our given is going to be the measure of ABC is 94. Then they're showing us that ABD plus DBC equals ABC. That's the angle addition postulate. Then we're substituting in 3x plus 15 for ABD and x plus 7 for DBC, and then 94 for ABC. So this is substitution property of equality. For 4, we need to simplify, so we're going to combine like terms. We get 4x plus 22 equals 94. Combine like terms. And then we take 22 away from both sides. 94 take away 22 gives me 72, so this is subtraction property of equality. And then we're going to divide both sides by 4, and we get x is equal to 72 divided by 4 is going to be 18. 18 is 36, and double 36 is 72, so x is going to be 18, and this would be division property of equality. Okay, so there we have the review notes for the Chapter 1 test.